This year, the Lunar Reconnaissance Orbiter celebrates 13 years of orbit around our Moon. And in that time, it has collected over a petabyte of data, the largest volume ever collected by a planetary science mission at NASA. Due to its success and continued operational abilities, NASA has awarded the spacecraft an additional extended mission phase so that it can continue gathering critical information on the Moon and help pave the way for future lunar missions. Going forward, the LRO mission will have 4 main areas of focus. The first is the study of volatiles, which are chemicals that easily evaporate or vaporize, such as water. In terms of lunar exploration, volatiles will be useful for things like creating rocket fuel and making oxygen to breathe, so they are a primary resource that future astronauts will depend on having. LRO will continue to provide new data for identifying which areas are rich in volatiles, and for cluing us in to how they may move around the lunar surface. Current LRO data suggests they may be frozen in permanently shadowed craters, in areas that receive some sunlight, and may be chemically locked in minerals on the Moon. This is helping pave the way for future missions like Viper, which will send a robotic rover to explore an area near the lunar South Pole, and ultimately, the astronaut-led Artemis missions. The second area of focus is on the Moon's interior, volcanic features, and the tectonics of the Moon's surface, because understanding the lunar surface requires knowledge of what's been going on underneath. Scientists want to figure out when the Moon was last volcanically active, and how current geologic processes, like moonquakes, could affect the safety of future exploration. They'll do these things by studying lobate scarps, as well as deep crustal and mantle composition that are exposed at the surface. Studying the Moon's history of volcanism and tectonics will also inform us about other planetary bodies in our solar system and beyond. The third area of focus is on the Moon's surface, its regolith and impact craters. We want to know how impact craters break down, and if different ejected materials might degrade at different rates. These studies will give us a better understanding of the mineral and chemical makeup of the lunar surface and subsurface. This information can tell us how the Moon has changed over hundreds of millions or billions of years. Studying the Moon's regolith and impact craters also informs scientists about space weathering, which can help similar studies looking at the Earth, as well as on places like Mars, Mercury, or even asteroids. The last focus area for LRO going forward is support for future missions. NASA has plans for numerous missions to go to the lunar surface during LRO's extended phase. Sending missions to the lunar surface requires planning, not only to build the mission, but to find safe and interesting landing sites. LRO is in a unique position to directly assist with some of those operations and science objectives. LRO can help identify landing sites by making maps that tell us what the surface is like, where there may be hazards to landers, and where there are interesting features to explore. LRO is also capable of helping land-in missions get simultaneous measurements from orbit while they gather data from the surface. After studying the Moon for 13 years, LRO has proven to be one of NASA's most valuable tools for advancing lunar science. And as it continues collecting data, the spacecraft helps lead the way for future exploration of our Moon.